Hello, I'm Vian from FTC 14133. Today I'll be talking about what our drivetrain is, how we coded our drivetrain, and I'll be showing some examples of our drivetrain running and some tools that we use to help us code the drivetrain. If you don't know what FTC is, it's a robotics competition for students in 7th to 12th grade to compete head to head by designing, building, and programming a robot to compete with other teams. So this year, well, there's in FTC, there's the in when you run the robot, there's two sections. There's the autonomous period, and then there's the teleop period or driver control period. Right now, in this video, I'll be talking about the autonomous period. In the autonomous period, it is completely predetermined. It has completely predetermined paths, meaning that it's the robot moving on its own and it has no human input into it. So starting off with our robot, we have a mecanum drivetrain. This means that it is omnidirectional. When a robot is omnidirectional, it can travel in any direction. For example, let's say a tank drive or your car can only move forward, backwards, and then left and right. Then, rather than um, rather with a omnidirectional drivetrain, it can move forward, backwards, left, and right, same like a non-omnidirectional drivetrain. But rather also it can strafe left to right. This means it can like shift left and right. So it can basically do complex movements and paths because of this. So to code our drivetrain this year, we used Roadrunner. Roadrunner is a motion planning library written for FTC, and Roadrunner allows for the complex path following and generation, like rotating while strafing or spline movements. The reason you can code these things like rotating while strafing and spline movements by yourself, but it's much easier if you use Roadrunner. On a robot, to implement Roadrunner, we also implemented odometry wheels. Odometry wheels are unpowered wheels that just that we can still record the position they are at. This helps us determine the position of our robot on the field. So this year we have a three-wheeled odometry system um, that allows us to have accurate paths or accurate tracking of our robot. When coding in Roadrunner, the Roadrunner graphs the field as so you can input that you want to go, for example, to any position. So this could be go to 50-50. So it'll go to the top right of the field. So what this makes us have to do is we need to find those coordinates that we need to go to. So to do this, um, I created a point grabber system where you can click anywhere on the field and then it will grab your robot, what position your robot would be if it was there. So this allows for, instead of constantly trying to calculate what position our robot needs to be, we can get a rough estimate and then tune it later when actually pushing it to the robot. But before even pushing to the robot, we can test our trajectories that we need to go to, that we are using. And this would be through Meep Meep. What Meep Meep is a um, path plan. It allows you to visualize your paths. So if you don't want to always just edit something and then send it to your robot again and again, you can quickly check it by meep, and it graphs it and shows your robot traveling the path, and it allows you for to uh, make use less time, so it's very makes you more efficient. Now you see some of our paths that we've made on on a video of it in real life. Additionally, with Meet Meep running to show what Meet Meep looks like compared to what it would look like on real life.